Okay, so let's discuss DAC once again. Okay, so introduction of DAC has already been completed. So how DACs work, what are their traits, that has already been discussed. Okay, so quickly I'm going to discuss the first type of a DC. Okay, that is okay. So the few things that we are going to discuss are digital to D2A converter. But what type of D2A converter we are going to discuss is this. Uh, Binary weighted resistors. Okay, as we have discussed that you can see that we are using a 4-bit 4-bit binary weighted resistor. So here, why it is called the binary weighted? First of all, the resistance here is 1k, another is 2k, next is 4k, and another is 68k. So these are 4 bits. So you can see that MSB is having the least resistance. Okay, so after MSB the resistance is 2k. Okay, and then it is 2 power 2k, that is the 4k. Then we have 2 power 3k, and then in the last we, okay, so these are the 4 that we are having right now. If suppose we are having 5 bit, so the next resistance would be 2 power 4k. So you can see that all the resistances are binary weighted. Okay, means their weights are as per binary. Okay, so smaller the weight of the bit, higher will be the resistance. You can see the LSB is having the highest value of the resistance. Okay, so and the MSB will have the lowest value of resistance. Okay, and then this is another resistance, that is the feedback resistance. Normally we keep it as the 1k. Okay, or the smallest resistance that we are using here. And this is op amp. We are using here op amp. Okay, we have discussed for op amp a little bit. I am repeating it for quick understanding. Okay, so the op amp, how the op amp works. Okay, so important things about the op amp is normally whenever we have a circuit connection like this. Okay, so what we say that op amp is connected is in the negative feedback, and in this case and only in this particular case, whenever the connection is like this, if the feedback goes from this direction to this, then it is not valid. Okay, okay, so it is, so it is not valid in this case. Okay, so what is the case, that the voltage of this V plus terminal, we call this terminal as the non-inverting terminal, and this terminal is called as the V minus terminal, also known as the inverting terminal. So this is non-inverting. Okay, so this is called the non-inverting terminal, and this is called, this negative is called the inverting. Okay, so this is the very important thing. Remember this thing always for an op amp. Okay, normally we consider that this is the voltage of V plus is same as V minus. So here in this circuit, the V plus is connected to ground, means 0. This voltage will also be 0. Another important thing regarding op amp is that current going inside the op amp is 0. We consider that the op amp is having infinite input impedance, so the current going inside will be 0. So the no current will go inside the op amp. Okay, so what we will have here, one current coming from here, another is coming from here, third is coming from here, fourth is coming from here. So all the currents will add together and will go here. Okay, then this current, same current will come here. Okay, if this is I, so the same current I will flow here. The current going inside will be 0. So these two things are important to know the functioning of the op amp. Okay, if you remember these two things, you can use op amp in your circuits. Okay, even if we do not know about the internal circuitry of the op amp. Okay, I hope this makes sense. Okay, if it is clear, so we move ahead. So let me take this. So this is all about op-amp. So now you know how the op-amp is working. So what next we can think of is how this all is working. Okay, so let me take one example. Okay, so suppose you can see here, these inputs are the digital inputs. A, B, C, D are the digital inputs. Digital input means they can be low or they can be high. Okay, here what is the level is 5 volt and the low level is 0 volt. Okay, so low level is 0 volt, and we do not know. Okay, depending on what digital word you want to convert into analog, okay, this will have the value. Suppose it may have like the digital word is this. So it means that A is 0. Okay, this is A. B is 1 means this is 5 volt we are applying at B. So this is 5, and B and C both are having the 5. This is also C, and this D again is 0. So we will apply 0 at A, 0 at D, and B and C will have 5 volts. Okay, so this is DAC, how we will apply the voltages. Okay, so now we'll look at general functioning of this circuit, because this bits may change. 4 bits may be, sometimes some bits may be 0, some bits may be 1. Okay, so they may change. Okay. So let me stop it here just to check it whether it's working.